Hey, welcome back again to the First Friday All Bugs Good and Bad 2014 webinar series. Dr. Skinner, we are very happy to have you today. He is a professor in Entomology and Plant Pathology Department and Extension Bee Specialist at the University of Tennessee. Dr. Skinner, thank you very much for being here today. I'll let you take it over.
Thank you very much, Danny. It's my pleasure to introduce this series of All Bugs Good and Bad. There'll be a lot of information coming all of you to share with your clientele, and I'd like to welcome a lot of the gardeners that are here to hear the presentation that I have for you today. I'm going to talk about pollination and the importance of pollinators to us as people, the importance of pollinators to those flowers and the reproductive system of plants, and how they interact one together. It's a multiple interaction. And I think it's a lot of fun, and I hope you don't mind having a little fun with this presentation. And so I'd like to begin, and my title of my talk is, If Flowers Are Restaurants to Bees, Then What Are Bees to Flowers? So think about that for a sec. And I'm going to put a few slides up here. These are my children. They're now well into their 20s. They had a ball carving that jack-o'-lantern. We wouldn't want to be without jack-o'-lanterns in the future, would we not? We couldn't have pumpkin pie for Thanksgiving. And we need these things to be able to, the bees and all of the other pollinators, native bees and honeybees, pollinate those pumpkin in order to have the fruit that we so much need and desire. This is our state tree. This is a quiz for Tennesseans. Should know this tree right now, and I'll get back to that later. What does that have to do with this sign saying Dunkin' Donuts? What I'm going to do is compare people to bees. And I'm going to compare restaurants to flowers. Let's see what they have in common. First, before I get into that, in the details, I'd like to mention how important pollination is for our agriculture in all of our states. I don't care where you live. This shows you squash production, and the bottom picture, you look at the bee in the lower left corner. It's getting pollen off that male flower. It has to get the pollen off the male flower and transfer it to a separate, distinct female in order to pollinate the flower. Those honeybees in the picture that you see in the lower shots are basically going for nectar at the base of the flower. They just accidentally get that pollen on their hairy body. The honeybee and many other pollinators are ideally suited and designed to be the perfect pollinator. Their parts are designed in that way. It's very amazing. When you get under a microscope and look at a bee, your eyes will open up. We need bees. Most of you have had lunch by now, but everything in those baskets requires or benefits substantially from pollination. If we didn't have the pollinators, imagine what it would cost to have somebody climb up a ladder and pollinate your apple, that apple that you ate for lunch today. Okay, and all these seed crops in the picture too, like onions, like carrots, they require pollinators to produce the seed crop that you as gardeners put in your garden and grow in your gardens. So it's important that way too. We have a huge value, and you can double these figures in the slide that I've got in front of you right now, simply because the price and the value of the crops that they pollinate keeps going up every year. In the back of this picture are almonds. This requires 1.35 million colonies of bees every year to pollinate that almond crop. That's a huge investment. And it's a very important industry as well that's blooming right now for those of us in other parts of the country. And I hope they have good enough weather so those bees can fly and do the job. In Tennessee, we basically do a lot of work in a number of extension programs and research programs on bees and beekeeping. We think we've done some good for the state in valuing colonies, saving 10,000 colonies and saving some money to the people and the beekeepers in our state. But this is a question I have for you. If flowers are restaurants to bees, what are bees to flowers? I'm not going to talk about one of those things. They are hungry. They are thirsty. They are robots, in one way of thinking. They are food, but not too long. They're pollinators, of course, and they're partners. This is real important because this partnership between a flower and a pollinator benefits both. One of these mutual things that we have to exist. Now, what about comparing flowers to restaurants? Both offer a food reward. Without the reward, the pollinator wouldn't go. And without the food, say in a restaurant, people would not go either. They would quit going, even though they had a pretty sign or a pretty advertisement. Bees need the nectar as a carbohydrate and pollen as protein. And so do we in our diets. Both advertise. So advertisement is real important to attract visitors. So I propose that flowers are signposts. They're advertisements to bees. Restaurants use signs to attract people. But without that reward, having nectar that the bees can, especially honeybees, can turn into honey to survive, they're going to be in big trouble. So those rewards and those flowers are very important. And they have adapted over evolutionary time to provide a success in the future. Have you got pollen? Hope so. Bees need that pollen to turn into more bees, as well as the protein source for all their exoskeleton and their other parts. They couldn't do without all the proteins in pollen. And they prefer, we found out health-wise, a diverse source of pollen. So they need all kinds of sources of flowers and sources of pollen, not just one sole source. So think about that and keep that in your mind as well. So what is the purpose of a flower? An advertisement. How does it advertise? Well, think of compare us to bees. You can get specific this way. A lot of visual cues. They're in colors that are visible to bees. Blue, white, and yellow are particularly attractive. Bees can see UV. We can't. But they can't see red like we can see. So it's still trichromatic, but different. What's really neat that in looking at flowers and looking at ultraviolet patterns, we determined they're nectar guides. These are like an arrow pointing out, here's where the nectar is. Put your tongue down here and you get a reward. They also have textures and form, depth, and shape that can basically, we know that bees can distinguish all those things. You look at how the texture of a surface, the way light is absorbed by a carpet compared to a shiny countertop in your offices. Form, depth, and shape can attract them from a distance as far as talking about a flower form, the depth of the particular blossom itself, and the shape can be distinguishing to a bee, and they can tell one different from another. When you look at this picture and your eye comes into this flower in the Asteraceae, you have different coloration in the petals. They're distance attractors, and they're very important for this kind of purpose. Also, there may be an odor associated with this as that pollinator gets closer to that flower. Now let's go back to that slide for a second. This is what we call radially symmetrical. All planes are equal. A lot of the flowers are designed in other ways. This shows a bumblebee on bee balm. Now this is a particular kind of mint flower that basically is in whorled branches. The branching patterns of plants are very interesting because the more flowers they have, the longer it will serve as an attractive unit to that series of pollinators. Not just blooming in one day, but of a whole series of days, like these whorled inflorescences or groupings of flowers. And that's very attractive to bees, honeybees, many native bees too. Native bees are really important as well as honeybees to pollination. We have over 4,000 species in the United States, and probably in each one of your states you probably have a couple thousand, many of which you're not even aware of. This shows a picture of what a bilabiate type flower with a keel. It's almost, if you're thinking like a bee, this is the platform for you to land on. Okay, the nectary is down here, down at the base of the flower in the lower part, a little bit to your right if you look at any individual flower on the left. But when that bee sticks its head in the flower, guess what happens? It's almost like a little button that, as it sticks its head down below, the exerted portion at the top comes down on top of it, okay, and basically deposits the pollen, if the flower is in the male stage, right behind the head of the bee. Now it goes to another flower higher up on the stem that is in the female stage, and it transfers the pollen because the stigma, the receptive part of the female, is directly in the same place. So the plant comes down on top and pops the bee on the back in the same place that a previous flower has deposited pollen. Yes, I'm being anthropomorphic, but it's certainly the easiest way to explain it, especially when you're given a webinar. Now, this particular state tree of Tennessee, those of you in Tennessee better know what this is, and it is the tulip poplar. And tulip poplar has these really nice orange nectar guides, ovals, okay, that are very contrasting with the background of the other petals. And basically, pollinators seeing this would go to the base of the flower where the nectary is, and they would get nectar out of that. This particular flower is female first. What's the purpose of that? Well, basically, it's to ensure that they don't get cross-pollinated, that they have to have pollen from another flower instead of its own self-pollen. And this ensures evolutionary safety over time. Oh, what in the world does plum tree have to do with anything? Okay, but if you're hungry and you're foraging for something to eat in Knoxville, Tennessee on Kingston Pike, and you wanted some Oriental cuisine, this may be very attractive to you. There's Chinese characters at the base of it. The lettering looks a little bit, like it would be Oriental. So that might be a tasty advertisement to you. This is a tour on Kingston Pike. Okay, it's also called Thunder Road if you want to go to the Jim Mitchum movie many years ago. And look at all those signs. If you're foraging for food, imagine now you're a person, you're foraging for food, and you see this array of signage. Well, that's quite, spectacular, but think of those signs in a way as flowers. Now, they each have a color that may distinguish them, and a shape even, like the Arby's hat, or something like that if you're hungry for roast beef. If you like Applebee's, then you take a look at the apple on the Applebee's sign. This is a signpost that attracts us while we're going to eat. Okay, here's another picture right here that is basically shows you some more signage. You can call it sign pollution, if you will. That's perfectly acceptable as well. But it's a busy highway, a lot of people going back and forth. You can say there are busy highways in pollination lanes too at sometimes, especially if you were out in the field like this. This is sunflower. It's a seed production field that I worked in Vacaville, California years ago. And those objects on those flowers that you can see in the foreground, they're not little dots, those are bees. Native bees and honeybees visiting those flowers for the nectar reward they basically have. But none of those great big heads in front of you have pollen. They're all male sterols. This is a seed crop. So the goal is to get the bees to move the pollen from little fertile sunflowers, which you hardly see because they're a little bit smaller in stature than these females. And the pollen the seeds that result, from cross-pollination then are a seed crop that is sent to the Midwest and other places in the country for production of oilseed sunflower. There it is up close. Now the bees learn that only the newly open flowers contain the most nectar. So that's where they are in a line right around the center. And this head will continue to bloom from the outside in for 7 to 10 days. This is also very adaptive for attracting pollinators over a longer time. Now where does your eye go with this picture? It goes right down the pipe. What you're looking at though, that's highlighted with those nectar guides in this morning glory, is pollen. Now this has some depth to it. And it's probably as well pollinated as much by butterflies as any other kind of pollinator. However, I wanted to get you the idea of look at the position where the plant has, quote, put the pollen that is readily dehisced. If a pollinator stuck its head in that flower, it'd get pollen all over its head in order to get food. And then going to another flower that may be in a female stage, you would have pollination. So quite an adaptive event. This is crimson clover. Many of you people ask me, what do I plant to attract bees for my gardens? And how can I do this? And how can I, support bees, even if I'm not a beekeeper? we can plant things with flowers that have food for bees in the form of nectar and pollen. Crimson clover in this picture is a very attractive one. It's also a great cover crop. What we're working with now at the University of Tennessee is trying to develop wildflower plots. We're having the most success with planting into cover crops with a no-till drill, because otherwise you have huge weed problems. It can be a real mess. So that's crimson clover, a good thing to use for bees. Uh-oh, I better get out of the way. That truck is serious. As I was foraging basically for food, I wanted to get the picture of the McDonald's golden arches there on your foreground, but I better move on. But now I need your patience, just for a second. If we look at this and we say that, there are nectar guides, I propose to you, if you look at this McDonald's restaurant like it was a flower, then we have French fry guides. So anyway, I'll get over that quick. But the idea is, bright colors, a lot of the things and features of restaurants and signs that attract us for eating are bright colors like red and yellow were predominant as I was walking around looking. Or you got pink and you got orange. Kind of flashy, but man, if you want a Dunkin' Donut, you're ready to go on that slide. Chick-fil-A, look at the C of the chicken. Okay. It's, again, using shape, using color as an attractive unit. Now, this is a picture that I took in California of some sunflowers to show you the idea of ultraviolet nectar guides. This is with normal film. This shot here is taken with basically UV. And the pattern, which you can see it's a darker pattern around the petal that the bee can see, but we cannot. I like this picture a little better. It's easier to understand. What we see is on the left of the evening primrose. What we think the bee sees, because they see ultraviolet and don't see red, is what is on the right. See that very contrasting bullseye pattern. That's what we mean by nectar guide. It's pointing, where is the food? Where do I go to get it? Well, if you wanted to have some fish or something like that, red lobster, you could go to that. The target sign is always attractive because your eye goes right to that center of that bullseye. Well, let's look at this flower. This is a true honeysuckle. This particular flower positions the parts right where the bee has to grab a hold of them to be able to grab onto the flower at all. Now, it's going to stick its head if it hasn't yet, but it unfolds its tongue from underneath its head, very well put together, and inserts it in the flower. At the base of the flower where it's attached is where the nectar is. But it can't get away from those pollen-loaded anthers as it goes to that flower. Now, it may go to the next flower that's in a female stage. This concept of being male first and then female may be very disconcerting to some of you, but the idea is that's what flowers do. And here's an example of that. This is on what we call a wild native sunflower that have both sexes in the same plant. And it shows you what the flowers are male first. And then as they go in, they push up. They basically end up, the stigma, as the female part pushes the pollen out and then spreads apart in as the picture indicates. So it's each individual flower, flora, is a male first. And a couple days later, it becomes female. And so everything changes. This is to prevent self-pollination. Now, flowers like this in an apple tree are interesting because they're known to change colors. So when they first open, they're all white. A little bit later on, as the bees visit them and they become pollinated, the petals turn and change colors to pink. The bees can distinguish the pink, and they don't waste their time on it. They basically go ahead and they go to the white flowers primarily. So it's a color cue to the bee that the plant puts out there. In a way, it's saving the bee time, and the flowers get pollinated. The plant gets to produce seed, and we get to benefit by eating the apples on that tree later on. Like Petro's chips and chili, and if you're in Tennessee, in big orange country, orange is a very attractive color. Okay, so that the marketeers and everything out and marketing restaurants, they take advantage of it big time. Okay, what tree is this? Look at all those flowers. Wow, you're basically in some kind of a real a heaven if you're a bee with all that food available. Each one of those flowers produces nectar. And it's a very neat tree, and it's very prolific. And after they become pollinated, they slightly change coloration too. And this is a black locust tree, by the way. And it blooms prolifically some years, and we have a real nice light whitish honey with a slight green tint to it. At least that's the coloration I see. Very sweet and very nice honey produced from that nectar. Here's another one that I came across in West Tennessee the first time I saw it. I didn't know this tree. But I was attracted to it because I thought a swarm of bees had landed in the motel that I was staying at. As it turned out, it wasn't a swarm of bees. The tree was full of them after the nectar of this basswood tree. Basswood is another tree that is very attractive to bees. Produces a lot of great food for it. It's an open flower, the bees have easy access, and they take advantage of it wherever basswoods are. Okay, when I was out doing my foraging, this is after I ate, I'm looking at these signs that people use to attract, attention to their business, and I'm sorry, this would be more or less repellent to me rather than attractive. But I did stick it in there because I thought it was curious. But I am attracted to a place that basically has a full parking lot in front of it. You don't really want to go to a restaurant that isn't attractive to other people. And I like the pumpkin on the roof, too, of the picture. Okay, here's another question for you, you gardeners. Some of you should know this. It's also an excellent plant to plant alongside your garden to attract bees to it. It produces nectar abundantly and pollen. It produces a darker nectar, resulting in a darker honey. It's almost like a tea or a coffee color. It's got a lot of flavor to it. It's buckwheat, very fast growing, and bees do a good job on it. And it also is very tasty if you like dark honey. Well, we can get attracted by signs from distance, and it all depends on what you're interested in, and it's an advertising. And so as you go, you have distance, and then you get closer attraction, and then you basically have a sign right in front of the restaurant, and no, we did not go in. Okay, I wanted to include this because it's an important topic. I'm adding it a little bit, but I did want to include this because I get a lot of questions on this. And how can you reduce the effects of pesticides on bees? Pesticides are really a controversial thing right now because there's a lot of information out there. The data we have isn't as good as I'd like to make whole house statements about whether some pesticides are bad or good. So I'm waiting until I see more data. But here's some general things that you can do as a beekeeper or that you should be aware of. You can use materials if you have to apply some kind of a pesticide to kill a pest. When the plant is not in bloom, okay, you can apply materials when bees are not there. They're not visiting. Often this will be very early morning, at dusk, or at dark. But it is crop dependent. For example, squash, bloom in the morning. And they start shutting down the end of the day. But this is at a time when it's very hot weather. It's a hot season crop. If you get overcast weather, the flowers are open longer, and the bees will be there longer. But when the flowers close up, say in the early afternoon, you could actually go out and spray that field, and you would not be hurting your pollinators. You can also move bees away during a spray event, but this takes time and effort, and very often beekeepers do not want to do this. They can cover up their colonies a little bit with some burlap, moist burlap or something to keep the bees in when the spray is going on. That can help. And also, I recommend you use materials that are the least harmful if you do have to spray when bees are present. And then the other alternative you have, which is one that many people are taking now, is do not use pesticides at all. Do some other tactic that is not a chemical or a pesticide related. I did want to mention that because I've got a lot of questions about it, and it's an important issue. Look at another flower that most people, that isn't a huge attraction to bees, but it's interesting to us. And it's an example of a flower that is female first. Those gardeners of you that like botanical names, it's called protogynous, means female first. And then later on, the anthers open. So the flower on the left is female. The flower on the right, you can see the pollen hissing on the edge of those anthers, is at a later stage. So a bee would have to went to a later stage flower, then went to another plant entirely to visit a one that's in the female stage to pollinate. And then you would have cross fertilization and not selfing. Yeah, one more little story to talk to you about that tells a neat little story. It's about bumblebees and how they buzz pollinate rabbit-eye blueberries. I know we have some people from Alabama, and so it's very appropriate for you. And so the idea is that bumblebee has a tongue that's long enough to visit that flower. And they buzz the flower. So listen to me when I change. I'm going to turn myself into a bee for a second, okay? The bee is going along doing its thing. When it buzzes the flower, it changes the pitch. It goes from buzz to zzz. Change in pitch, that buzz releases the pollen from the anthers. You can do the same thing, example of it, by using a tuning fork, as is done in some tomatoes in greenhouses. But this bumblebee visits the flower and releases the pollen, okay? And then, the bumblebees are great pollinators of this blueberry, which is like an upside-down bell. You notice in the upper right flower, those stick-like objects sticking out are old pistils. That's the old female stage. Blueberries are male first, then they turn into being female. But another thing with blueberries that you need to know as a gardener is that you have to use different cultivars to transfer the pollen from one cultivar to another because they're not self-compatible. They will not self in the same cultivar. So you have to buy different cultivars of blueberry in order to cross-pollinate. And so the buzz pollinators do a great job on their own. But here's the next scenario. Enter the honeybee into the picture. Now, honeybees, their tongue isn't long enough. And the bee that's in the lower left picture, where you basically see it's actually going through a hole. Well, where'd that hole come from? Well, it's because a carpenter bee perforated the corolla or the side of the petals to get at the food because its tongue is too short and it's got these sharp mandibles and mouth parts that can punch a hole right in there. So the honeybee learns that it can stick its tongue through the hole the carpenter bee made and get the goodies that way. So it's kind of being a nectar thief, if you will. But they've proved over research that basically honeybees move the pollen around that's been released by carpenter bees and bumblebees, excuse me. And by the way, Danny and Kathy, this was work done in Alabama by a friend of mine named Jerry Payne. Okay, so that's an interesting whole scenario, though. Everywhere I've gone to look at blueberries, I don't care what state it's been in a wide variety of different blueberries, I've seen this situation to the most part. So I find that very interesting, coadaptation. Now, I do have a take-home message for you. I'd also like to thank some people. I'd like to thank our University of Tennessee staff that helped put together a lot of this work, and their hard work went into promoting these websites. At the University of Tennessee, I encourage you to use these sites where they're available in Tennessee or any other state to give you research-based information that's so important to understand bees, beekeeping, pollination, and other aspects of this. For your gardens, maintain your bees, and to keep you healthy as a person. I also would point you to the e-extension site, the Bee Health Community of Practice. And we have 483 pages of information about native bees and honeybees. Examples, 55 videos, YouTube, Facebook, and Twitter. We're into social media. So please stay tuned to those sites over time, and we'll have more information for you as time goes on. Okay, it's our job to provide new information, make it research-based, make it timely. And we did it for you. And go Vols on Bee Health site. Okay, now, what else have I got? Okay, I had to do this. I was looking for a picture of a skunk. My only excuse was I couldn't find one that I could like, but I came across this guy named Skunky, and I had to have a picture of that, so bear with me. And actually, this is a picture of a honey house in Tennessee that was painted so well, I just had to take a picture of it as well. Now, if you've got questions, I thank you for being a patient audience and putting up with a little bit of audio interruption. Thank you very much. I appreciate it.
Dr. Skinner, thank you very, very much. I'm sure we're all going to look at flowers a little differently now. At this time, if anybody has some questions that you would like to ask Dr. Skinner, maybe you could type those in the chat box now. Dr. Skinner, can you hear me?
I can hear you.
Hey, thank you. I see that Ms. Humphrey is asking a question about mason bees. She's asking, what about mason bees? Now, I know that mason bees are very important pollinators, native pollinators, especially for some of our fruit crops.
Oh, yes, they are. There are a number of native bees. Mason bees are in the group, basically they're the leafcutter bee group family, Megachilety. And what they are, they're the genus Osmia. There's several different species of this Osmia that you've heard of. The blue orchard bee. There are other mason bees that basically go out and collect pollen. Their currency is more based on pollen than it is on nectar, because they're annual colonies. So pollen is a better reward for them, and they are excellent pollinators. Their colony size, they're individuals, so they're not like a colony, a group of living together. They're solitary bees. They nest gregariously in tubes and stems and whatnot, and they can be very good pollinators. And there are sources of them online. If you were to Google and look at that, or send me an email, and I'll see if I can get you some information on that.
Thank you. I think we have another question. Do the carpenter bee holes hurt the blueberry flower or the plant?
That's a great question. Carpenter bee holes and the piercing of you would think that they would hurt the health of things. They do not. That surprised me. That was a question I had. And from what I understand, it's not that much damage. I mean, I think it has to affect something. But there is so much fruit set. And the fact is that they are promoting pollination in a way by doing this. They're increasing visitation to the plant itself by honeybees that maybe without these perforations you wouldn't have that many bees visiting it. So by sheer numbers, yeah, I think the bulb bees do a great job bee for bee. But they start the process. And then other bees take advantage of the fact that there's a food source. Hey, it's pollen, it's protein, they go for it.
Thank you, Dr. Skinner. And there's another question. I've seen a couple questions related to pesticide use and colony collapse. They're asking specifically about residual pesticides and the effect of pesticides on bee health.
Questions? Because some of these things, when you're talking pesticides, you have to be pretty specific about what you're asking. And it is potential, in talking about residual effects of a pesticide, yes, you could have residual effects. And some of the residual effects can be reduced if the pesticide is the formulation has a sticker that sticks to the leaves and not so much to everything. And so some of the effects can be reduced. Somebody else had some question about GMO crops on honeybees and was linked to the bee die-off.
Yes, sir.
At this time, I would have to say no. Most of the experts that I've consulted on this say there's not enough information available on GMOs to say they're harmful or they're not. Although as a scientist, I think we need to know more information. So I'm not entirely satisfied with that answer, but that's what we have right now. We don't know.
Thank you, Dr. Skinner. There's time for a couple more. I see one that's being asked about systemic pesticides that are absorbed by the plant, about their lingering effects on the health.
And what you're probably talking about are these systemic pesticides. They're seed treatments. They're called neonicotinoids like imidacloprid and others. Yes, these are a potential problem. We know they're not good. We don't know how much or how uniform or how, the question is, it becomes a specific question for a specific area, a specific crop, and a material, and how it's put on the crop, how it's put on the seed, whether it's using a dust. Companies have responded to the dust type treatments that we proved were causing problems in row crops, and they're now coating the seed differently. That's reducing the effect. We need more information on these systemic pesticides. That's why I'm part of a study this year to look at that very question. We can't really say point-blank answers until we answer our questions, until we know and we have more data. So we need more data to be able to. What is a GMO? It's a genetically modified organism. Okay.
I think we have time for a few more questions. Please note that the link for the survey is in the chat box, and you can copy and paste the link that you are seeing on your screen, and we would really appreciate if you took this survey. We also have a few poll questions coming up. Any more questions for Dr. Skinner? Dr. Skinner, we thank you very much.
Okay, I see one question that I can't answer yet, and I'm going to try to find out the answer too, but I think it's important, that's why I'm going to point it out. Somebody asked about this tobacco virus that's jumped from plants to bees. And I think you're right, it is a tobacco ring virus, and I want to know what the story with it is too. And it popped out on the press, but I don't know the data yet. So that's something that if other people know about that, I'd like to have you send me a reference, and I'll be glad to look at it. Somebody sent me one earlier about a specific bombus impatiens. I will check the reference out, and I appreciate you doing that. Basically, you've got to consider each situation. You have to be careful in making general comments, especially about pesticides. And I wish we could, but I'm very careful in what I say about it because I've seen too many times that it's in one area a whole lot different than some other place, different plant, different system.
Thank you, Dr. Skinner, and we're going to have some poll questions pop up on the screen now. If you all could take a few seconds to answer those for us. Dr. Skinner?
Yes.
All the polls are going. We just wanted to thank you again for being here today. That was a great webinar. We appreciate it. And we hope to see everyone next month for the First Friday series where we will be talking about termites, biology, and their control.
Thank you, Danny. It was my pleasure, and I hope this was worthwhile to the audience. And I would recommend that you listen to more of this, of all bugs, good and bad.
Thank y'all, everybody.
Thank you.